My one quick note about hyperbolas is that in a hyperbola, unlike an ellipse, A always comes first. We're going to take a quick review of ellipses before we move on. As I mentioned in the foldable notes, please make sure you've filled those out before viewing this video. As I mentioned in the hyperbolas notes, a hyperbola is an ellipse that is simply turned inside out. So there are some very similar characteristics to hyperbolas and ellipses. We'll go ahead and identify the vertices at 5, 0 and negative 5, 0. The co-vertices along the minor axis at 0, 2 and 0, negative 2. We're going to identify the foci here by using c squared equals a squared minus b squared. So that means that the foci are located here and here at negative square root of 21, 0, and the square root of 21, 0. The center is the origin, 0, 0. Therefore, the equation in standard form is x squared over 25 plus y squared over 4 equals 1. Definition of hyperbola is given to you in your foldable notes. Now we're just going to focus on graphing using the critical values in the equation. A is always bigger. Sorry. A always comes first, so that means A is 2, B is 3, and we will use c squared equals a squared plus b squared to determine it. Remember to use that shortcut to remind yourself which one goes with which. It is always the opposite symbol. That is 9 plus 4, which is 13, so c is the square root of 13. The center is located at negative 2, negative 1. This is that one where if you were not careful, you're going to see your center values switched. Your major vertices, we're going to hold off on those for just a second. Since it's not at the origin, it's not as easy to see, so we'll go ahead and graph it first. So moving at negative 2, negative 1, we'll put our center there. We're going to go up 2 units and down 2 units. The reason I know that is because the value of A is associated with the Y. I'll move that number that way. Likewise, the value of B is associated with X, so I'll be moving those vertices left and right. These are the conjugate axis. This is the transverse axis. The reason I know that is because Y comes first. I know that these 2 points right here are the points at each branch of the hyperbola. Okay? It's at this point that I'm going to draw that fundamental rectangle, like this. Once you've drawn the fundamental rectangle, you draw your asymptotes. And now you can more easily draw your hyperbola. A sketch of it would look like this. Remember that your hyperbola is going to get very near to, but not cross, the asymptotes here and here. All right, now that we have all this information graphed, now we can fill in all of these critical values. The major vertices, those are the ones located on the transverse axis. Those are the ones that the branches of the hyperbola touch, are located here and here at -2, 1 and -2, -3. Your co-vertices, those are the ones on the conjugate axis, are located here and here. -5, -1, and 1, -1. The slope of the asymptote is easy to determine. You count up and over. It's your value of A over your value of B in this case, but don't always rely on that because A and B can be switched, so let's just call it rise over run. From the center, I rise 2 and run 3. Therefore, the slope of the first asymptote will be 2/3, and the slope of the other will be -2/3. So I can simply write it as plus or minus 2/3. You could go a step further and write the equation of the asymptotes, but in this particular case, we're only asking what the slope of the asymptote is. The domain in this particular problem, remember this does not go vertical, although it indicates that it does. It's the way that the line was drawn. It's like a parabola in that particular instance, so the domain is all real numbers. The range is a little bit different because one branch stops here and then it picks up again on the other side. So we have to acknowledge that there's that gap there. So we start at our smallest value, which will be -infinity, and we will stop at -3. Included. Draw our union, and then we will pick it back up again at 1 and continue on to positive infinity. Number 2. All right, so first of all, A is 3, B is 4, and using c squared equals a squared plus b squared, c equals 5. Our center is the origin, 0, 0, and we'll stop here and we'll graph before we fill in the rest of our critical values. So since A is associated with x, I will count left and right 3 units. Since B is associated with y, I will count up and down 4 units. I will continue with my fundamental rectangle and my asymptotes. Now, since x comes first, this is the transverse axis, therefore the branches of my hyperbola will come off the sides, and this is the conjugate axis here. So I'll sketch a drawing of that like so. Now that I have all this information, now I can determine what all of my critical values are. I'll go ahead and fill in my foci, even though I did not fill those in on the previous one. I should have. They will be outside of the fundamental rectangle. The major vertices are going to be on the transverse axis at -3, 0 and 3, 0. Your co-vertices are going to be located on the conjugate axis at 0, -4 and 0, 4. Your foci will be located at -5, 0 and 5, 0. The slopes of your asymptotes, rise over run, rise 4, run 3. Therefore, it's going to be plus or minus 4/3. The domain on this now has the gap, while the range has all real numbers. So now we'll go ahead and start with our smallest value at -infinity. Go to our first major vertex, which is -3. Pick it up again at the other major vertex, +3, and continue on till infinity. Now number 3. This one looks complicated at first. All it is simply getting it into standard form. The way we'll do that is by dividing all the numbers by 144. That gives me y minus 4 squared over 16 minus x plus 2 squared over 9 equals 1. Given all that information, we'll go ahead and fill in A, B, and C. A is 4, B is 3, and using c squared equals a squared plus b squared, we'll determine that the value of c is 5. The center of this is located at -2, +4. And now we'll stop here and graph. -2, 4 is my center. The value of a is 4. A is associated with y, so I'll count up 1, 2, 3, 4, and down 4. B is associated with x, so I will count left and right 3 units, here and here. Draw my fundamental rectangle. Draw my asymptotes. Sketch my hyperbola. And now I can fill in my critical values. Remember, since y comes first, this is the transverse axis, and the hyperbola will come off the top and the bottom of the fundamental rectangle. The major vertices are located at -2, 0, and -2, 8. The co-vertices along the conjugate axis are -5, 4, and 1, 4. Slopes of the asymptotes are rise over run, that's plus or minus 4/3. The domain is back to all real numbers, and the range has the gap, starting at the smallest value at infinity, going to the lowest major vertex at 0. Picking up again at the other side, 8, and continuing on to infinity. The foci are located, here. No, let's try again. The first dot was correct. Here and here, 5 units away from your center. Question number 4. In order to keep the notes shorter, let's go ahead and have you fill out question number 4 on your own. Bring that back to class, and we'll discuss your answers in your groups, making sure that you guys all have the same responses. Question number 5. Write the equation of the hyperbola given. In this particular problem, I'm going to find my center first. My center is located at 2, 3. I'm going to recognize that the hyperbola is on the left and the right side of the fundamental rectangle, making this my transverse axis, which means that x will in fact come first. X minus 2 squared minus y minus 3 squared. Now I'm going to determine what A and B are by counting from the center to each major and minor vertex. 1, 2, 3, that gives me 9. 1, 2, that gives me 4, and it's always equal to 1 in standard form. Wilson's comet is approaching Earth along this course right here. Shortly after, Horn's comet follows along the same path, but now it's shifted. Okay, so that means that I've got some transformations that I've got to follow through on here. Okay, so the first thing I'm going to determine is where this thing is located on the graph. And it is located at 1, -3. If you see there, got to be careful. It is not located at 1, -3. It is instead located at -3, +1. So that is just an example of how if you switch your ordered pairs, not looking carefully, the difference between your placement is very much changed. Okay, now I'm going to shift it 2 units to the left and 3 units down. So I'm going to continue it to the left here, and then I'm going to shift 3 units down. 1, 2, 3. Placing it right there. That is going to be at -5, -2. So it's going to be y plus 2 squared minus x plus 5 squared. And now nothing else has changed about it, so that's still 4, that's still 36, and that equals 1. Pay really close attention to what your center is going to be. Don't make the mistake of putting it backwards.